and the cost of seed production can be reduced by at least 40 to 50%. And if you see the history of the two-line technology was way back when I did my PhD, we developed 8 TGMS lines, and many of the early findings are there in this manual that we published long back. But this technology never lifted up, and we understood that one of the major reasons, despite the advantages that it has, like I told you, maintainer can be avoided, choice of parents are broadened, and the genes are major genes, so it can be easily transferred. There is no negative effect of the cytoplasm that the hybrids do have if you have the WS wild abortive cytoplasm. It has also higher seed production ability than the 3-line system, so we can easily cross 3 tons through this approach. And 2-line hybridized generally yields higher than the 3-line hybrids by 10%. So that makes it attractive. Now the key element here is to produce a hybrid parental line that will become sterile, can become completely male sterile at 24 degrees centigrade or even lower than that. So this is our objective here, to breed this. And this was not available in the past. And recently, over the last few years, we could develop this particular line, and we have created a new study group called the 2-line study group, where a set of like-minded companies have come forward to fund this research, and we have been successful in going forward in testing and validating for commercialization of the 2-line in India and other parts of the world. And if you look at one of the 2-line hybrids here, 554, which was tested in Hyderabad in 2018, and we can see the advantage over US 337 and MTU 1010 by 21%. And this is another old TGMS line using the older version, which is also doing good and did well in Hyderabad. And we had also done in Varanasi last year in 2019, where it outyielded IRRI 6444 gold by almost 7%, and this 554 did with 6.5%, and over SAVA 127, 13, and 12%. So this is very important to understand that the 2-line hybrids are important features that can lead the way based on especially reducing the cost of seeds and the heterosis, increased heterosis. 554 has a climate smart traits like drought and low input, or we can call it as nutrient use efficiency is higher in these hybrids. And these are being validated and tested in the different sites in India now. And I'm very optimistic about this hybrid's performance, which is already nominated in the Philippines National Yield Cooperative Trials. Now, to summarize the whole talk, what would be the future hybridized research direction? Now, climate smart hybrids are being evaluated now in vulnerable target regions in different parts of the world. Newer climate smart products involving heat, cold, elevated levels of CO2 are the key areas, including ozone. These could be one of the few futuristic climatic conditions would warrant us to work on these ones, including nutrient and water use efficiency. So the hybridized program currently is dealing with these areas for our research, and we are trying to look at the interactions that could be also interplays would be there between these target traits, and how these could be pooled properly by good breeding design, and that's what we are looking at. And designing new CMS lines and TGMS lines that matches the market requirements of 3-line and 2-line hybrids are very important. And innovative approaches like genomic prediction of heterosis and artificial intelligence could narrow down our combinations that we would like to test, and cost reduction and precision heterosis breeding is going to be the future. 2-line hybridized technology would become a commercial reality in tropical Asia, provided we have the usable low temperature or the low critical sterility point below 24 degrees centigrade. If you have something like 23 or 22, I'm sure we will be able to get it right. And the genomic editing tools, I don't know, many countries still are keeping this under the GM category, but sooner or later, this would be understood as one of the future techniques, and it would become as a routine. And it will be easy for us to edit target traits and quickly get to the help for the farmers in addressing some of the key target rates correction, and we will be in a better situation in this regard. And hybridized technology cannot be lifted without the human resources being trained. And this is one of the very key aspects where we are very much in the HRDC as well as other platforms. We are very much concerned for training more human resources that can understand how to breed climate smartness in their parental lines, and how to develop hybrids, and how to do seed production in their own respective regions is very important. And IRRI also has we would like to look at the future to create a center of excellence for hybridized research and extension that would cater these type of things in the future. And this is something which is very much practical, keeping the consideration of food security. I think wise investment should be in this direction to create these type of centers of excellence for such an important technology. And of course, socioeconomic impacts should be tested, should be tried for the climate smart hybrids in the coming years, especially in Asia and Africa. I think I will try to conclude here, and I would like to acknowledge all my team members, especially in the GSR project that was funded by Bill and Melinda Gates team, and the entire GSR team that participated from CAS, Chinese Academy of Agricultural Sciences, IRRI, and IRRI, and NARIS partners from 16 countries are all duly acknowledged. We have our rice breeding platform leader, Hans, who has helped us to project this whole new dimension of the hybrid breeding platform, hybrid breeding cluster in a different way. And also, I like to acknowledge Remy's contribution to take it to the private sector in a very energetic manner, and his team also comprised of Ajay, Linga, Roberto, and so my team from Anna, Pauline, Tini, and also the HRDC Advisory Committee, hybridized breeding team involving Lito, Kaloy, Eric, Anna, Christian, Donna, Roy, Bea, Jonas, Lolit, Makto, and Sinan. I really appreciate their help and in making this possible. And our breeding clusters approach is written in this caption here: developing superior high-yielding heterotic rice hybrids that meet market requirements, adopting genomic tools, and to strengthen and invigorate the hybrid seed industry through the Hybridized Development Consortium by providing elite hybrids and parental lines and technical know-how. With this, you can visit our websites, HRDC website, for more information. And IRRI's 60th year, I think we are marching forward to go beyond rice. Thank you very much.
Thank you, sir. We have some question in Q&A box. That is after the screen share, the polling, and then Q&A.
I'm not able to open that. Just a minute.
In bottom.
I have to stop. I think stop sharing it. Right?
Okay. So yes.
Okay. Now it comes actually. Okay. Good.
Yes. So, okay. So we put some of selected them, but it comes randomly. So you can answer few of them from that Q&A box section.
Where should I find that?
It is that.
Okay,
okay. Yes. 34. Okay. It's so
34 questions. My goodness. Okay.
You are interesting.
Yeah, it means a lot of interest it has generated.
Yes.
Anyway, the hybridized varieties released in India are yet to release. What are the varieties and what rates and yield rate, tons per hectare? Is it successful in India or not? I think you should understand that ICR, Indian Council of Agricultural Research, with its partners, especially IIRR and IRRI and NR, National Rice Research Institute, are members of the HRDC, and we are sharing with about 26 private members from India alone. who have utilized our materials, and not only our parental lines and materials. Also, we are sharing with them many of the varieties from the HRDC, which they have been testing. And I'm sure many of them would be in their coming to their pipeline for release and utilization. As of now, we have not any major release in India in terms of direct release, but in the Philippines, we have made 17 releases. I think I will go to the next question.
Yes.
Can you explain how artificial intelligence predict heterotic combinations? Yeah, this is these type of tools are basically coming from some outsourcing done by Computomics, and other agencies are there which can use artificial intelligence to predict the hybrid combinations. Basically, this uses the genomic knowledge. The genomic sequences are known. The environments in which they are to be grown, this is known, and their phenotypic traits are known for a given set. And then in the places where they are grown, once that of the founder lines are known, then it becomes, it's just like putting more and more data into it. It starts, it's a machine learning process, including the GBLUPs, and the BLUPs would kind of machine learning process. And the artificial intelligence basically breeds on this and accumulates more and more information as it becomes more intelligent by itself. And it will say, okay, use these combinations. These are the best ones for you. I think this is the way it does the artificial intelligence, but it needs a lot of information in the first place coming from different trials. And this gets fed into it repeatedly by very good algorithms of machine learning. And that's how the artificial intelligence grows. It becomes, it grows with time actually. And then we have a grain number per panicles in hybridized varieties. Is it 300, 400? It is not important what is the grain number. It is ultimately the grain yield. Sometimes there are compensation mechanisms. In some panicles would have more, something like 350 to 400. Or some would have 250 to 300 grains per panicle. But then the number of tillers, number of productive panicles, and the sterility at the bottom of these pipelets, all this matters in the total grain yield. And I would suggest watch out for the final grain yield per plot. That would determine ultimately the yield. And of course, these are yield component rates. It matters a lot, but higher with more productive tillers is very essential. The next question is from David Chen. Sorry to clarify, what are the desirable traits and characteristics of variety that makes it better for direct seeding, in case I was unclear in the previous question? I think the direct seeded conditions, basically the traits that are important. You see, when people will throw direct seeded in dry bed condition or wet bed conditions, basically in wet bed conditions, you need anaerobic germination tolerance, because the moment you throw the seeds, you will inundate with water, and the water would not allow the germination of these seeds, but it will control the weeds. So for control of the weeds, you need to keep the water film over the surface of the, so that you can control the weeds. And therefore, anaerobic germination tolerance is very vital. Then under deeper depths of soil, especially in dry bed sowing, sometimes the seed falls toward lower depths. And that ability to grow from that, from 2 centimeters below depth, it should be possible for these. This should be a trait as such. And likewise, the herbicide tolerant resistance. And I think many of these traits are very important. Early vigor, and if you had seen that figure on that, I had illustrated most of these traits there. I think you can look at that. And herbicide resistance tolerance, like what we are working with the BSF, Clearfield and Provisia technologies are there. Also, herbicide genes can be incorporated that will take care of the herbicides that we can apply on these plants to make it really effective. Another one from anonymous attendee, burden or on farmer for seed every season as hybrids segregate. I think one has to understand hybrids have to be used only one season for its exploitation, F1. Once a farmer buys the seed, they have to use one season and not to grow the F2. And the farmer benefits from the higher yields of more than 1.5 to 2 tons in conditions, especially in favorable rain-fed conditions. The advantage is sometimes even more than 50%. And in irrigated conditions, it touches 30%. So the extra yield that he gets, it is possible for a farmer to invest on it. And we have seen this in time again in the rain-fed areas in India. The hybrids are prolifying in these regions where the farmers are really poor, but now their income has increased because of the hybrid technology, where the farmers are gaining on the advantage of the hybrids over the inbreds. And in fact, it is not a burden when you see the profitability in the front. So that is something people always feel that is the way. But I would suggest people to look at the advantage. And the seed rate is only 16 kg per hectare. And we are trying to go below that even. So that is not, when you compare with inbreds, which is 35 kg per hectare, sometimes 150 kg in direct seeded conditions, people are growing. And when you compare this with 16 kg, it should not be difficult. Next question I see is from Afsana Ansari. What is the highest seed yield of hybridized in the world, both in CMS yield and F1? I think the best yields can touch up to 6 tons in the best yields. I'm telling you, it can touch even 6 tons in cases where China has reported. But to be realistic, on an average, you can touch 3.5 tons in China. They can do it. In India, the average seed yields are touching 2.5 tons comfortably, and we are viewing whether we can cross the 3 tons in the tropical regions. So this is very much influenced by the temperature and the climatic conditions where you produce the seed. So one has to understand that CMS yields are largely dependent on the type of CMS lines that you use. So outcrossing traits facilitate the higher seed yields, and CMS yields also becomes much higher than the A by R seeds to the same level, and even in fact more because of the synchronous flowering, and it is more than 3.5 tons we can expect in case of A by B in Indian conditions. And how can we get these hybrid rice varieties in Pakistan? We have a partner in Pakistan, the Rice Research Institute in Kalashakaku is getting it is a member of the HRDC, and the private sector who are interested from Pakistan, they can become members of the HRDC as well, and they can at $20,000 per year, but they can really make money when the time comes for licensing. You have to pay a very low upfront, licensing fees, which is just like 2.5% of the given hybrid, and 1.5% for restorer, and this is very, very low level of licensing fees, because IRRI wants to use these funds not for increasing our coffers, but we want to increase the investment into hybridized research, and this money goes back to the public's utility, where we bring and plow back this money and bring more rich dividends to the hybridized research. And this is how this whole pattern works. And therefore, the public sector receives the seeds free. The private sector receives for token money of for licensing this at a later stage. So I would encourage all private sector, whether it's from Pakistan, India, or any other country who are interested for similar questions, they should contact HRDC Secretariat. We have a HRDC website. I would encourage people to become members and take the benefit to their country and to their region. And I told you, public sector are free to become members. Next question coming from Anuj Kumar. Sir, what is the future of hybrid rice in India? And now majority of the area is under pure line varieties. I think, Anuj, you are not aware that currently the area under hybrid rice is 3.5 million hectares. And this area is likely to grow very rapidly in the coming days. When the food crisis is going to hit, people will switch the button to hybrid rice, because that is the only viable approach any planner would look at it. You don't have any other alternative approach at this moment that can give 25 to 30% increased productivity. And I really, people should align themselves with this concept in their mind. What is the next question, Miraj? What is the difference between hybrid rice varieties and improved varieties? The major difference is the hybrids have early vigor, and they can be combined with any type of tolerances by complementing the traits in two parents, and you bring it into the hybrid. The grain quality can be customized based on the grain quality parameters of the two parents. So you can really address the hybrid varieties as we want. So it is what is in the parents is what is the hybrid is all about. So you want to have good quality hybrids, you can have good quality, you can have basmati hybrids for that matter. But the bigger difference in improved varieties is 25 to 30% yield advantage is the biggest factor that helps the hybrid varieties adoption. And then Supraja requesting the best method for development of hybrids. I think I showed you all the methods, but IRRI is now engaging on the one rice breeding approach based on the genomic selection. And we are also employing the genomic selection in the heterotic pools and for the parental line breeding. And this is one rice breeding is very, very essential and will become the future way of breeding, both for inbreds and hybrids. And many countries and including the CG centers are already adapting to this one rice breeding. So this is a new area which will be soon, you will be listening to it to more. Okay, so next question is Acharya wants to know restorer line or maintenance line are from wild variety or cultivated type. The gene that came from the sterility gene that is located in the mitochondria comes from wild abortive cytoplasm, which is coming from Oryza sativa spontanea, which was the first source of WA cytoplasm, which was discovered in China, and later it was shared to IRRI, and from IRRI to all the Asian countries, these lines were developed and into the CMS backgrounds, and they were freely shared with the region. So the restorer genes are available in indica backgrounds, plenty of it, but in japonica you don't have restorers, and that is the reason why two-line approach is very good approach to create interspecific hybrids between indica and japonica. Now coming to Raj Kumar, how non-allelic QTL pyramiding have advantage over allelic QTL pyramiding? Under what circumstances we can sort non-allelic QTL pyramiding? I think this is the advantages are relative between non-allelic and allelic pyramiding, but the key factor lies on what type of traits that we are moving and how we are preparing the alignment and the benefits of that. So generally, when you are using different donors and common recipient parents, and these non-allelic segments for a given target trait contributes to the drought tolerance or salinity tolerance, and whether it's allelic or non-allelic. But generally, non-allelic segments help in pyramiding or pooling the best part of the QTLs together. And as well as, I think you have to look at our paper that was published on the GSR breeding approach in the Theoretical Applied Genetics Journal recently in 2020. So I went up. Is that the question remaining?
So there are so many questions. If
okay, yeah. I thought that was the end of the page actually.
No, there is so many. If when you feel it's okay, we can stop it. So
yeah, you let me know. But I based on the top priority on the top, I'm just telling them.
Okay.
But if it's similar question, I will if I had answered. But they're all different questions. That's very interesting for me too.
Yes.
The wild rice Rufi-Pogon cross can be a valuable pre-breeding material. Of course, any wild resources can be very useful. XA genes like XA23 came from Rufi-Pogon. Sometimes the yield genes have been cloned and from Rufi-Pogon. I think these are approaches where you can utilize these type of materials. Then David Chen puts a question, rightfully pointed out there are certain materials such as fertilizers, which are, originates from non-renewable resources. Assuming climate smart would be the ones that is most efficiently utilizing. Is there a quantitative measure of nitrogen efficiency between common varieties and climate smart varieties? I think this is a very important question. I think we published a recent paper in PLOS One, how this could be evaluated. And really, the phosphorus is one of the biggest challenges, because this is going to be completely, you will not have a renewable source for this. And as we go along, spreading towards 2050, the challenge would become more serious as we go along. And these countries are located in Morocco, Russia, and all these countries. Whether they will trade these type of fertilizers even would be a question mark. How long they will keep mining these rock phosphates. And so these are really big questions. And of course, use efficiency, we actually use the partial factor productivity and the agronomic use efficiency for mapping the QTLs for that. But there are certain, the best approach would be the physiological use efficiency, which is very, very, physiological efficiency is one of the most important approaches to measure the differences between nitrogen use efficiency. And definitely the hybrids would stand out because of their heterotic combinations there. There will be much in higher use efficiency if we incorporate the genes rightly. Recently released hybrids and varieties in India, I think ICRIP has regular trials, and many of the companies put their hybrids there. I think one should refer to that. Sorry if I just skipped anything by mistake. Okay, Deepan, Roy. Global Rice Research Array, HRDC doing the same thing for IRRI. Is it a question? Yeah, are Global Rice Research Array and HRDC doing? Yeah, kind of, because what eventually these type of arrays or these type of multi-location trials would be similar in some approach, but what we are trying to do in the new one rice breeding approach, we'll be combining many of these things into one single way of testing these materials. And it will be very robust in its testing approach. And we are expecting very soon this will be laid out. And Hans is leading on this approach. And we will be seeing this happening soon. Sudhakar asked, nice presentation. Can these lines be accommodated to Arabic? Of course, these lines, many of these hybrids, as well as the inbreds that we developed are well adapted to Arabic conditions. And we have shared many of these lines with many countries in the past. How can we introduce two-line hybrid in our country? I think at this moment, two-line hybrids, we are sharing with the two-line study team, where we are trying to completely validate the commercialization of two-line hybrids from private sector point of view. And immediately these type of materials would be brought to different countries for testing. And the best way is to look out for this study group that has been formed recently in 2019. And this is a very, very robust set of companies, and public sector institutions have joined hands to see how this can be commercialized. I think once that is done, many of these things would eventually reach different countries. Do on rice have anything to do with climate proofing? on rice, to my understanding, it's a joke rather than a thing, that it is bird proof, I believe. More than that, sometimes this awns keeps these birds away. Sometimes that is the only thing, but generally on traits are not preferred in many parts of the world. But there are places where people like on also, because I told you it gives birds not damage it, because it gets it protects from the birds. So anyway, that is it also gets stuck up in their throat or something like that. So this is on rice, but I doubt whether it has any climate proofing. When we when we evaluate hybrids for yields or other characters, can we use for other commercial hybrid or check or standard varieties? When we evaluate hybrids for yields, okay, so we always use the hybrid checks and the best commercial market checks. So whenever the yields are comparable or bringing some new traits into them, or is robust in some manner, the people can easily evaluate it, and then based on the grain quality and the acceptance of the farmers, definitely one should be able to commercialize them. The next question is the anonymous attendee: what can we use hybrid rice in organic farming, because it need more quantity of nutrients, or so how to fulfill requirement of nutrients in organic farming? So of course, hybrid rice can be used in any type of farming. Farming approaches can vary, doesn't matter. And such hybrids, especially use efficient hybrids, should be a very perfect fit for this type of thing. But I would not encourage organic farming in the sense to keep food security when food security is becoming a challenge. Even if you put all the nutrients, they are not going to give you the best returns. And if you are going to use organic farming with organic fertilization and to replace the chemical fertilizers, I think that is going to be a challenge. But hybrids are always good in utilizing any kind of nutrients compared with inbreds. So it should not be a problem in adopting hybridized for organic farming. So you're welcome to use if it is your viewpoint. When we, okay, where are so many questions. Okay, so Arun asks, sir, whether photosensitive rice varieties can be converted to photoinsensitive, or any possible way to make it flowering. Yeah, of course, this is through mutation breeding. Of course, you can mutation or gene editing can be done, but GM is not in many plots of the world still. So you knock down this gene, you can make it insensitive. And all those things can be done. I think it's possible. And through breeding also it is possible to replace the gene.